In this tutorial, we are going to see gate question asked in CSE department in the year 2025. The question is, in a 4-bit ripple counter, the period of the waveform measured at the last flip-flop is 64 microseconds. Just for illustration, I have shown a diagram. It is not part of the question. If you consider a ripple counter like this, they measure period of the waveform. That means this may be the second flip-flop or last flip-flop, across which if you measure the output, we get a waveform like this with some logic low and logic high. The time interval it takes, the total time interval is nothing but clock period, which is about 64 microseconds. For about 32 microseconds, it is at logic 0. Another 32 microseconds, it is at logic 1. So this 64 microseconds is a cycle or period of the waveform measured at the last flip-flop. They ask you to find out frequency of the clock signal. So how will you find out frequency of this clock signal? In order to solve this one, let us try to understand the fundamentals of ripple counter. Here I have taken a 4-bit ripple counter because in the problem itself it is mentioned that we use a 4-bit ripple counter which contains 4 flip-flops, like for flip-flop 1, flip-flop 2, flip-flop 3, and 4, right? So a 4-bit ripple counter, and they measure the waveform at the last flip-flop. Last flip-flop means the one which receives the clock is the first flip-flop. The one at the far end is nothing but last flip-flop. Here they measure the output signal, and the output signal time period is 64 microseconds. We need to calculate frequency of the clock signal. Okay. Now, the next important thing we need to understand is that a ripple counter acts as a clock divider or frequency divider. So whatever the input signal we apply, it gets divided by 2. So if you can observe, I apply some clock pulse to the first flip-flop. Again, this flip-flop stage divides the frequency and produces a signal having half of the input signal frequency. The same thing if I apply 125 kilohertz signal as clock input for the second stage, it produces a waveform with half of its frequency, nothing but 62.5 kilohertz. Every stage divides the clock signal by 2. That is what it represents. By the way, let us have a quick review. How do we get this divided by 2? Suppose if I apply a clock pulse like this, one after the other, every negative edge toggles the flip-flop output from 0 to 1 or from 1 to 0. So at the arrival of every stage, the Q output of the flip-flop gets toggled. As you can observe, this is the 4th clock whose negative edge changes the QA output from 1 to 0. So changing from 1 to 0 takes place at the 4th clock pulse. Again, when the negative edge of the 5th clock pulse arrives, it changes from 0 to 1. In this way, the QA output toggles. Similarly, the negative edge of QA toggles QB. So every time negative edge of QA appears, QB changes from 0 to 1 or from 1 to 0. In that way, QB toggles. The QB act as clock input for QC and QC act as clock input for QD. In that way, every negative edge toggles or changes the state of the previous stage, right? So this toggling process is taking place. Again, if you observe, the time period of this clock pulse, for example, having negative and positive, if it is about 30 microseconds, let us assume it is going to be 30 microseconds, the time period of QA output will be double the amount of this. That means if it is 30, the time period of this one will be 60. So 60 microseconds is the time period for this. If I measure this one, the QB output, again, it is twice that 60, it becomes 120 microseconds. So every successive stage, the time period gets double. Because time periods get double, nothing but frequency get half. So here what I would like to convey, every stage divides the clock input by 2, especially the frequency is divided by 2. That means time period is multiplied by 2. Now the same thing in the form of relationship it is given. Frequency is 1 by time period. Now let us apply these fundamental concepts into the given problem. Now let us solve this. So in the question it is given that output of last flip-flop, they measure the time period of the waveform is 64 microseconds. Now they ask you to find out input signal frequency. So first let us convert this time period into frequency. The relationship between frequency and time period is 1 by time period is nothing but frequency. It gives you the value of some megahertz. You convert into kilohertz for convenience. It is 15.625 kilohertz. So output signal frequency at the last stage is 15.625 kilohertz. Suppose I want to measure the frequency of this signal, means it is moving one stage in previous to this. If I move from left to right, the frequency get divided by 2, right? Suppose if I move from right to left, then it gets multiplied by 2. So here it is 15.625. I multiplied by 2, it becomes 31.625 is the frequency of the signal I measure at this stage, isn't it? So applying the same concept, if you can see in the diagram, it is clearly mentioned that the last stage having the signal waveform of 15.625 kilohertz, the previous stage which multiplies the frequency. When I move from left to right, it gets divided. When I move from right to left, it gets multiplied by 2. Okay, apply the same thing here. It becomes 62.5. Here it becomes 125. And finally, the very first stage where we apply the clock pulse is having a frequency of 250 kilohertz. This is what answer for the question. Thank you.